Hello everyone, my name is Jidapa and I'm working in Dr. Liu's group. I'm a second year PhD student and I would like to present my project, Cybersecurity of Electric Energy Distribution Grids. Because the traditional power grid is trying to move toward the smart grid that allows remote sensing, monitoring, and bidirectional flow of data and electric energy, is more vulnerable to the power grid cyber attacks. In September 2024, Reuters reported that U.S. utilities are experiencing a 70% increase in cyber attacks. So in this project, we consider two types of individual cyber attacks. One of them is a false data injection or FDI, which means that the attacker would try to falsify the data and inject those falsified data into the system. On the other hand, we also consider the replay attack, which means that the attacker would try to capture the authorized data, keep it for some time, and send it to the system later, causing the misunderstanding to the system operator. We have simulated those attacks in our test bed, and then we plot the response of the system as shown in the figure here. To detect those individual attacks, we use MAC for the false data injection. We compare the MAC at the control center and the MAC at the feeder remote terminal units. If they are different, it means that there is likely a false data injection attack. For the replay attack, we compare the difference between the timestamp when we receive the data and timestamp when we send the data. If it exceeds the tolerance limit, it means that there's likely a replay attack. With those topology, we develop our intrusion detection schemes to capture the coordinated attacks. Coordinated attacks mean there are sequence of attack that the attacker has been attempted in order to cause more harm into the system. Our detection scheme can consist of two-level detection. For the level 1, we detect individual attacks just like what we explained in the previous slide, and then we generate alerts and send it into the level 2 IDS. The level 2 will gather alert information, process them, and then predict the attacker objective and also the attack path. For level 2, our methodology including alert processing, where we remove redundant alerts and cluster those alerts together. And then we have system impact quantification process that we simulate their attacks on our simulation too, and then we see how it will impact the system. And then at the end, we have the model-based enforcement learning that we keeps improving the reinforcement learning policy until it reach one of the objectives and learn the optimal path toward it. That's how we can predict the attacker objective and also the attack part. In terms of the testing, our DCI algorithm has been tested on the modified IEEE 13 node and also the actual Dukes test feeder. The result for the modified IEEE 13 nodes has been shown on this slide. We started from some initial attack that the attacker is trying to cause to the system, and then we predict the next target components that are likely to be more interesting for the attacker, and then we predict the attack objective. Because these all happen in the cyber layer, we can capture the falsified data and also the replay attack before those reach to the physical components, and so we can stop it before the actual harm happen into the system. So to conclude that the coordinated attacks is the sequence of attacks that cause more damage into the system, and we trying to develop an algorithm to detect those coordinated attacks using their two-level IDS. So at the end, we can know what components in the system are likely to be the next target of the attacker. we can send a warning to those components so that it can drop tagging data packets and raise the warning signal. That's how we prevent the physical harm to happen into our system. And thank you for your time.